Hey guys, I hate to teach the lesson 8.5 this way, but hopefully it will help clarify some of your questions if you're still unsure about it. Basically, it comes down to this. Sometimes you have situations in which there's a constant rate of change, and sometimes you have situations when there's not a constant rate of change. And so basically all you're doing is looking at situations and telling me, yes, there's a constant rate of change, or the situation represents a constant rate of change, or no, it does not. So let's just brainstorm a minute situations in which you have a constant rate of change. Let me see here. Situations in which there's a constant rate of change. Earning $5 per hour. So that your pay would increase at a steady rate for every hour you worked. So after 10 hours, you'd have $50, right? Another situation in life where there's a constant rate of change. Recipes, baking. I always go back to that, but I don't know if your cake, for every one cake you make, it requires 2 eggs. So if you made 3 cakes, you'd have to use 6 eggs. Okay, that's just a constant change. Okay, how about the other way? What would be an example of a situation when there was not a constant rate of change? Maybe the temperature over time, outside weather, temperature over time. How about your exercise pattern? You run, walk, jog, then you run, walk, jog. If you were to show your distance over time, that would be not constant. So hopefully that gives you the big idea. Okay, so within this lesson, they're going to be asking you 2 questions, basically. One is going to be find the constant rate of change, or is there a constant rate of change, which you already know how to do because you found the rate of change last lesson. The next question is they're going to ask you whether a proportional linear relationship exists between the 2 variables. Okay. If you look at this problem here, you'll see we have a linear line. In general rule, if there's a linear line on a graph, there's generally a constant rate of change. So real quick, if we look at this constant rate of change, on the x-axis, on the y-axis, we're going up in increments of 5, right? 5, 10, 15, 20. On the y-axis, we're going in increments of 1. So let's pick some points on the line. If we extended this, it'd fall right here. Points that are easy to read. And so we know that after 3 weeks, the plant's grown 5 inches. So, and after 5 weeks, it's grown 10. So basically, we're increasing 5 inches for every 2 weeks that go by. Do you see that? This represents 5, this represents 5, this represents 5, and then of course 2 over. So our constant rate of change in this situation is 5 inches in 2 weeks. Okay, so I told you there were 2 questions. One is, what is the constant rate of change? And then once you find that, you're supposed to explain if a proportional relationship exists. Well, let me write the ratio here of the rate of change, which is 5 inches per, 3 weeks, right? Okay, so a proportion is what? A proportion is 2 equal ratios. So let's just take 6 weeks, for example. Set up a proportion here. If the plant grows 5 inches in 3 weeks, how much would you expect it to grow in 6 weeks? Well, we can use the side-to-side method. And 3 times 2 is 6, so 5 times 2 is 10. Well, look. After 6 weeks, it didn't grow 10. It didn't grow 10 inches. It grew more than that. So this is not a proportional relationship. Now, the easy way, instead of writing two ratios and setting up a proportion, is to just look to see if the line goes through the origin, 0, 0. And it doesn't. It's going to go through the y-axis at about -1. So that would have been the easy way, is just to look to see if it goes through the origin. And if it doesn't go through the origin, then it's not a proportional relationship. All right, I need everybody to get out their notes. This is found at the bottom of, or after the notes we took for lesson 8.4. So you have the notes for 8.4 rate of change notes, it says at the top. So flip the page over and let's finish taking notes where we left off. So find that for me, please. In the problem before, you'll notice we set it up by proportion, right? So what is a proportion? Two equal ratios. Very good. And then it says, when looking at a linear relationship or a straight line on a graph, there is a proportional relationship between the quantities at every point, then you will know that there's a constant rate of change. Absolutely. Like we said, but lots of the questions in this lesson are two-folded. One, what is the constant rate of change? And then two, does a proportional relationship exist? So obviously, if there's a proportional relationship, there's going to be a constant rate of change. So, but also remember, you can have a constant rate of change and a non-proportional relationship, and that will be the case if the linear line does not go through the origin. You can finish reading these notes if you want. I'm going to go ahead and flip over to the next page and do the practice problems on the back. Okay, it says find the constant rate of change for each linear function and interpret its meaning, period. I don't know why that's missing. And then it says determine whether a proportional linear relationship exists between the two quantities. All right, so let's name a couple pairs of points here. Let's just use these first two. We have, looks like 8 over 12 up, and then here we have 16 over 8 up. Okay, we're baking cookies. And flour remaining in however many cookies we use. Okay, let me just, sorry, I was just looking at the meaning. And 24 over 4 up. Okay, let's find our rate of change for the first 2 points. Change in y over change in x. So change in y, 12 to 8 would be 4. Change in x would be, and that's actually going down. 12 minus 8 is 4, and 8 minus 16 is -8. So you can tell that it's a decrease, and the line is decreasing, so it's negative slope or negative rate of change. And let's see if that holds true for these two pairs of points. So your change in y is, well, 8 to 4 is 4 over your change in x. Okay, that would also be -8. Okay, so 4/8 is the same thing as 1/2, and we know it's negative. So what are we talking about here? Interpret its meaning. What does this mean? It means we're losing a cup of flour for every 2 cookies we bake. So every 2 cookies requires 1 cup of flour. That's what it means. And then determine if a proportional linear relationship exists between the two quantities. Okay. Let's go ahead and write a couple ratios of flour remaining to cookies and see if that exists. So let's just write a ratio for this first point. What is this? 12 cups flour per 8 cookies. Let's look at this next point here then. 8 cups flour, 16 cookies. Well, that's not a proportional relationship. Plus, it doesn't go through the origin, does it? The line doesn't, this does not go through the origin right here, so not a linear proportional relationship. Okay? You know, when I go to this next problem and just look at this, the rate of change, I'm noticing for every 5 minutes, 60 gallons of water is being added to the pool. And I can just tell without doing all the changing y over changing x stuff, like this is 60, 60, 60. Just adding 60 each time. So the change in y is 60 gallons, and that's constant for every 5, 10, I mean, this is going up by a constant rate of 5 minutes. So truly, I could even simplify that if I wanted. I could say the constant rate of change is 12 gallons per 1 minute. That's water's pouring out of there. Okay, so that's the constant rate of change, and I can just see that, you know, from the table. Now, does a proportional relationship exist? How can we tell? Well, one thing I can tell you for sure is I can write a function rule, a proportionality equation real easy, I should say. 5 times 12 is 60 times 12 times 12 times 12, right? If I stuck in a 0, 0 times 12 would be 0, which means if I was going to draw a graph of this, this would go through the origin. And my equation would be y equals 12x, because my rate of, you're just filling up at 12 gallons per 1 minute. So as long as it goes through the origin, then it's a proportional relationship. So yes, a proportional relationship exists in this situation. Okay, I hope that better explains things, and good luck with your homework. The answer key is on Canvas, so if you're struggling with your homework or 8-5, just, use the answer key as a guide. Okay, thanks. Bye-bye.